Hello, fellow game makers. In this video, we're going to start a small four-part series on how to replicate the bullet board from Undertale. And it's going to include all the features you'd need for your own fan game, including resizing, text display with typewriter and text sound, of course, clamping soul movement, and having bullets that only appear inside the bullet board. Okay, so a little bit of a disclaimer, this isn't going to be a tutorial. This series isn't going to be a tutorial on how to make actual combat. And the reason that is because I'm making this tutorial to help a fellow YouTuber out, that being Fluffy Noel, or Lel for short. She's making her own little series on how to make your own Undertale slash Deltarune fan game, and she already said that combat is going to take a while to get into. So I thought that I'd be able to help her out by making this little tutorial series because the bullet board is incredibly easy to make, and even if her tutorial goes to Deltarune style combat, what you learn here is still applicable to that. You would just need a few changes in the code. So without further ado, let's start our first episode. And as you might have seen on the game preview, it's going to be all about resizing. And so first we're going to delete our current bullet board asset. Delete that. And our current bullet board sprite asset. We're going to start from scratch. Okay, so first we'll make the needed sprite. Let's go in here, create sprite, resize the canvas to be 16 by 16. I'll explain why that is in a moment. Clicking edit image, pick a 5 pixel brush or whatever size you want to. That's not going to be really important, it's totally your preference. Grab the outline rectangle tool, you can just press R for that and create the bullet board outline. Then just press F to grab the fill tool and fill the inside. And that's it. Let's just name it as bullet board, or you can name it SPR bullet board, whatever you prefer. And this by itself isn't going to work, and I'll show why that is. Let's just go into the room and drag the sprite into our asset layer. And if we try to stretch it in the room, it's going to happen like this. And that's because whenever you stretch an image in GameMaker, you're just taking the base image and stretching it in the Y or X axis. Yeah, so what can we do about that? Well, it's pretty easy. It's pretty simple. GameMaker has a feature called 9 slicing, and just as the name implies, it lets you slice your sprite into 9 slices. It was added specifically to make rectangular boxes scale appropriately in either direction. So in the preview here, we can just stretch it and we can see that it scales as it should. Nice. So let's go back into the room, add our sprite again, and scale it, and it still doesn't work. Why is that? Because we didn't toggle activate 9 slicing. You'd be surprised how often you forget that. Okay, now back into the room, and look at that. It's scaling nicely. Now, before we make the actual object, one last thing we need to do is come in here and set our origin to bottom center. We're doing that because whenever you stretch an image, it's going to start stretching from the origin point. So if you put the origin point in the center, it's going to start stretching from the center, meaning it's going to stretch upwards and downwards, and we don't want that. We want it to stretch upwards only and stretch in both sides. So bottom center is going to do that. Start stretching from the bottom and in the center of the x-axis. Okay, let's make our object. Create object, let's call it O bullet board. Immediately assign the sprite Okay, so how are we going to do this? Let's set the create event. And we're going to do this by manipulating two inbuilt variables. Those are image x scale and image y scale. And these are the variables that determine how much you stretch a sprite. And they work multiplicatively based on the sprite's natural size. So an image scale of 1 means no change in size. An image scale of zero point 0.5 means half the original size, and 2 means twice the original size. Now, we're not going to be setting these variables directly in the step event because if we say that our image scale is 5, that's going to immediately set it to 5. And we don't want it to immediately reach the new size. We want it to smoothly increase until it reaches our target size. So we're going to add two variables for that. Sorry, three. Those are our target x scale. Let's set it to 5 for now. Our target y scale. Let's also set it to 5. And SPD, which is going to be how quick it increases. Let's set it to 0 0.8. We can't write speed because that's a native variable along with image scale and a few others. So yeah, we're gonna use SPG or some other name. So in the step event, we're going to add this. If image x scale, let's work with x scale first, is less than our target x scale, then inside the if check, image x scale equals min. And the way the min function works is that it always returns the smaller of two values. So if we were to put something like 0 and 1, it would return 0. If we were to put 1 and 2, it would return 1. And 1, 2, 3 would also return 1. You can put as many values as you want inside it. So we're going to write this. Image x scale plus SPD, comma, target x scale. And what this will do is that at every step, it's going to set our current image scale to itself plus our SPD or our target X scale, whichever one is smaller. So it's going to keep increasing by our SPD until it reaches our X scale. And we can test that right now. Let's put it to something like 15. Go into the room and drag the bullet board in the instances layer, and let's run the game. And look at that. It's already stretching. But it's only stretching to increase. We also want it to decrease. And to do that, we just do the reverse operation. We're going to say else if image x scale is greater than our target x scale, image x scale equals max. And max is the inverse of min. It returns the greater of the values you input. Image x scale minus SPG target x scale. And now, our target x scale is going to increase or decrease depending on how, sorry. Now our image x scale is going to increase or decrease based on the value of x scale. I apologize, it's my first recording. And for that, we can just add a simple check down here. We're going to say if image x scale equals target x scale equals 0. So what we should be seeing is that the bullet board will increase to 15 in the image X scale, and then when it reaches that, our target X scale will be 0, and so it will decrease. Let's run the game, and look at that. That's pretty neat. Now, of course, we can just copy all this and do the same for the Y scale. Just come in here and replace every X with a Y. All set. Now, before we run the game again, what I'm going to do is I'm going to set up an alarm. And an alarm event is pretty simple. You just put some code in here and it runs whenever the alarm counter reaches 0. So we're going to say target X scale equals I random range. And this just gets a random number between what the numbers you put in. So we're going to say I random range between 15 and say 30. And then we can do the same for the targeted Y scale, and then we reset the alarm. Let's say alarm 0 equals 60. And don't forget to call the alarm somewhere that's not the step event. If you keep calling it in the step event, it's gonna be resetting the timer at every step, so the alarm is never going to trigger. Okay, so let's run the game. And look at that. That's exactly what we want. Now you can tweak the speed to be faster or slower depending on your needs, but that's it. You've already got a functioning bullet board. Now, let's add a cool little effect where you can choose one side to scale first before it scales the other. So you can scale the sides first before it increases the height and so forth. So we're going to do something like we did here, in that we're going to have an if-else check on which side of a preference variable, let's declare it here, preference equals an empty string. Now you could just copy paste this inside the if-else statement, but it's really unnecessary and is just going to bloat your code. So what we can do instead is we can declare all this inside a function. And to do that, it's very simple. We just go in here and say resize x equals function, open brackets, and then curly brackets. And now everything we write inside here is going to run whenever we call the resize x function. Now you could also write it like this: function resize x, brackets, curly brackets. But what this is going to do is that it's going to declare resize x as a script function, which means it's going to have its own script index and be stored in memory. And we don't need that. We would need that if we were working with custom functions that we want to call in various objects, various parts of the game. But in this case, we only want to call resize x inside the bullet board because we're only going to be resizing the bullet board. So by declaring it like this instead, we're declaring it as an instance function, meaning it only exists inside the bullet board, like these variables. These are instance variables. They only exist inside the bullet board, and when that is destroyed, they get deleted, much like, and so this function will be deleted when the bullet board gets deleted. So we can just copy paste this in there. You can press Ctrl X to cut it out, and then Ctrl V to paste it in. Let me just, there we go. And then down here, resize y equals function. Just do the same, open curly brackets, cut this out, paste it in here, Then we just do some managing and there we go. Now we can just call these functions down here and we'll have the resizing still. So we're going to do it like so. If preference double equals x, or you can say lowercase x, it doesn't matter. Resize x, make sure to always put brackets since it's a function, otherwise it's not going to run. And then if image x scale equals target x scale, resize y. And then here we can do the opposite. Else if image y scale, sorry, again, it's my first recording. If preference equals y, resize y, and if image y scale equals our target y scale, resize x. And then in here we can add a default. Else resize x, resize y. Okay, so now let's declare our alarm again. Alarm 0 30, and let's set our preference to x. And there we go. It's first resizing the x scale and then resizing the y scale. So now let's do the opposite. And let's decrease our speed because I think it's a little too fast. And look at that. It's first resizing the y scale and then in the x scale. And if we declare our preference to be nothing, it's going to resize in both at the same time. Would you look at that? And so, yes, that's it. That's the basics of bullet board resizing. I'll just delete the alarm here since we don't need it anymore. And I think, yes, that's it for this current video. In the next video, we're going to talk about clamping a player's movement so they can't leave the bullet board. And I'll try posting a video every weekend since I have a lot of work involving my actual real world work, and I also have to work on my own game maker project, so I'm not able to spend a lot of time here. But hopefully, you were able to learn something new with this video, and hopefully, by the end of this series, you'll be able to tackle whatever it is now, whatever it is Leo throws at us with her combat system. So yeah, thanks for watching. Leave a like if you liked the video, leave a comment if you have anything you didn't understand, anything that needs clarification, and I'll see you later.